Hello everyone. We are going to be solving the daily Leetcode problem given on July 22nd yesterday. Maximum erasure value. This is 1695. Before starting this problem, we shall have a small motivational quote. Even Einstein failed in school but never stopped questioning, learning, and building the impossible. As a developer, you are not defined by your bugs, failed builds, or moments of frustration. Every error is just a stepping stone to a better solution. Einstein didn't let step backs, setbacks stop him, neither should you. World's greatest innovation often starts when you refuse to give up. So never give up on your dreams, right? So I want to bring up such quotes. I hope this motivates you to take up problems and become good at data structures and algorithms. Let's continue with the problem statement here. You are given an array of positive integers nums and you want to erase a subarray containing unique elements. The score you get by erasing the subarray is equal to the sum of its elements. Return the maximum score you get by erasing exactly one subarray. An array B is called to be a subarray of A if it forms continuous subsequence of A. That is, if it is equal to A of A of L plus 1, A of R, some for some left and right index. Okay. So we need to remove certain subsequence from an input array nums such that there is only unique values. That is one thing. Uh, so let's understand this. I guess this problem statement is little tricky, but yeah, let's understand through this examples better. So uh, so let's say we start off with uh, this nums array as an input, and we start from this character. So we consider 4 as our first character. So let's say 4 is my first character, and I don't see 2 being a duplicate character. So I also add this up, 4 plus 2. And once I see 4, which is a duplicate character, and my initial sum was 6, so I might, if I want to include this 4, then I might need to remove this 4, also start a new pair. So I quickly jump from 2 plus 4 plus 5, which is not something that we have seen so far. So either 6 or this sum. This sum is equals to 17. So it would be 6 plus 6, 12 plus 5, 17. So this is the maximum continuous subarray which comes with 2, 4, 5, 6, right? So okay, so now let's say we can look at this example where we have given with multiple duplicate characters 5 to 1, 2 5 2 1 2 5. So we obviously see 1 5 to 1 and 1 to 5 being repeated. So the optimal subarray that we can come up with would be either 1 to 5, right? Or yeah, so this is the only possible way that we can come up with. So and the sum of it would be 8, right? This also is 8. So any of the maximum value that we can come up with will be our solution. So let us look at the approach that we are going to take to solve this problem. So the approach that we are going to used to solve this problem. Let us see that. So one thing that I obviously get after looking at the problem statement and the example, we obviously need to only consider the unique set of elements. So set would be a good data structure to store only the unique set of values. So unique set of values. And next we can have a sliding window with left and right pointers, and we can iterate through each of the nums array and move our left and right pointers such that if nums of right is not unique, then we can move our set to the right value exclude the right value, and also move the left pointer. If nums of right is not duplicate, so let's call this is duplicate, then we if nums of right is duplicate, then we remove all the left values and also include the right value. So that's what we have here. So I will uh, put this into two conditions. So let me rewrite what I meant here. So let's say nums of right. So we continuously move the right pointer, and there are two possibilities. If it's duplicate, then remove from set and move left pointer, and update set such that items from left and right are only and right pointers only exist. And if it's not duplicate, simply include the item. Okay, so we can go about our solution this way, but I would like to walk through with an example. Maybe I will take this example where we had 1 2 5 2 5 2 and 5 2 1, right? So let's say we start with left and right pointers initially here. So we continuously move this right pointer here, and uh, once we are our right pointer will be here, then our left pointer should be here, right? So this should exclude these two elements. So our set will be populated with 1 2 5, and once we are at here, so we should also be removing these two and only consider this as a new set. So the previous two values should be moving out of the set. So that is also something that we should do when we see a duplicate character. Okay, so once we have this one, so again we see right value already has a duplicate. So we remove this value and we consider 2 5 with an updated set, and our left pointer shifts to 2 and 5, right? And again here a right value, once we are here, so our left value shifts here to exclude this part, and our new set will be 5 and 2, and again our set for, comes to this one. So this way our sliding window pattern gives us a set of numbers only with with unique set of values, and we should always keep tracking the maximum of it, right? So that's our approach. So the way that we are going to code it up is we are going to initialize a set left, up and right pointers, and we are going to, while right pointer is less than or equal to nums dot length, and also set does not contain nums of right. uh, if it doesn't contain, uh, we can add to set, else we should move, so move left pointer to make set contain only unique values, unique values. So this part of the else piece is a crucial thing. So let us see how we can build it up. So, so uh, in order to have only unique values in the set, we can iterate through the set. Let's say we can iterate till the set says set dot scene nums of right. We can keep deleting the values till the, and we can also increase the left pointer by one by with each of these operations, right? This would form the else part. We, instead of having to do it this way where we are saying if this one do this add to set and also else part, we could kind slightly refactor our logic such that uh, we still can have a while loop, uh, right less than nums dot length, and we can simply say if while scene dot has nums of right, scene has nums of right, then we can delete the scene. Scene would be set, and we can delete, and we can also increase the left pointer. So this while block moving, so moving this uh, else part that we thought about to a bit higher would always give us will always put us in a situation where the scene set will always contain the unique set of values and the left pointer is always moved. Now we can simply add the new incoming right pointer value, and we can also say sums less nums of right, and max sum also we can calculate, and we can keep increasing our right point. So this is our idea. So let us quickly move to the lead code editor and let's code it up, and let's see how the solution comes up. So we are doing this scene has nums of right. So if there is a new right value already present in the scene set, then we remove all the values from the scene set such that we increase the left pointer and also reduce the current sum until there is no duplicate value in the scene set. So that's what we are doing here, and we are good to add the new incoming right pointer value. So here we had the new incoming right pointer value, and also we increase the current sum value. So current sum, and also with each addition we also calculate the max sum that we have encountered with, and also we continue to increase the right pointer till we reach the end of the nums array, right? And once we end this while loop, we should be having a maximum which we can return, and that should solve the problem. All right, so this is uh, 21 has current sum. So one tiny mistake which I could see here. Okay, this should solve the problem. Yeah, so this should solve the problem. Time and space complexity uh, of the solution would be of n. Time complexity would be of n, and space complexity obviously would be of n, as we are storing it in a set. And we still have two loops here, but still uh, we are only adding certain pieces of elements to the scene set and also removing it right away. So uh, yeah, this is still a O of n operation, right? Because elements are added and removed from the set at most once. I hope that makes sense. Let me know in the comment section if this what do you feel about the time complexity, if it is really O of n or O of n square time complexity, seeing these two while loops here, right? Hope to hear comments section. Hope to hear some doubts or thoughts about how what the time complexity of this problem would be. Until then, thank you.